Formal language and automata. In the first module, we are going to see about the finite automata and the regular expression. So in this session, we are going to see about the introduction to the automaton. So what is the automaton? A mathematical theory of a simple class of algorithm. It is important in the computer science and mathematics. So we are calling this as a theory of automata, and it has two primary applications in the computer science: one, modeling of finite state system, and second one is description of regular set of finite words. And there is many emerging applications like computer algorithm and the program, verification and specification of a protocol, designing of a compiler, searching of pattern in a text, then natural language processing. So these are the some applications of a automaton. And we can say this algorithm as a recipe. So why we are saying it as a recipe means it contains the solution for the problem. So that means it recipe tells how to solve the problem. So initially mathematicians were interested in dividing the line between what was and what was not algorithmic. So based on that, they have classified the algorithm into two approaches. One is a complexity theory and another one is a language theory. See, according to the running time, it is known as a complexity theory, and according to the type of memory used in implementing them, and it is known as the language theory. So these are two classifications of algorithm. Next, we are going to see what is automata. So the term automata is derived from the Greek word which means the self-acting. Okay, it is means the meaning of the Greek word is a self-acting. So the automaton is a abstract self-propelled computing device which follows the predetermined sequence of operations automatically. So this automata theory deals with the logic of computation with respect to the simple machine, which is referred as the automata. Okay, so automata means it is a plural word and automaton means it is a singular word. And through automata, computer scientists are able to understand how machine compute the function and solve the problem and the more. Okay, so by using this automata, the computer scientists are able to understand how machines compute the function and solve the problem and the more. So as I said, abstract automaton is an abstract model of the machines. So it will perform the computation on an input by moving through the series of states or a configuration. So at each state of computation, a transition function determines the next configuration on the basis of finite portion of the present configuration. So once the computation reaches an accepting configuration, it accepts that particular input. So we will see one example. So here we have taken the example as an electric switch. So here this is a switch. Okay. So this is a switch. So this is a battery and this is a bulb. So here what we will do, if we want to glow the bulb, means what we will do, we will switch on it. Okay. So here we are going to see what is the input. So what is the input here? So input is a switch. So why input is a switch? By pressing the switch, based on that it will bulb will glow or it won't work. Okay, then what will be the output here? So here the output is bulb. So output is a bulb. So bulb, if it is on, means it will light the bulb. So bulb will light. Then what action we are doing here? So the actions we are doing is flip the switch. Okay, so here action is flipping the switch. And what is the state? So here state is on and off. So there is two states, on and the off. So this is the automata. It is one of the automata we are using in our daily life. And apart from this, there is more examples we are using in the daily life, like fan regulator, automatic door controller. So these are some examples for this automata. Next we are going to see about the family of automata. So there is four families of automata. One is finite automata, push down automata, linear bounded automata and the Turing machine. So here the simplest automata is the finite automata, and the most complex and the powerful automata is the Turing machine. So for each and every automata we are using the different languages. For finite automata we are using regular language. For finite automata we are using regular language. Then for push down automata we are using context free language. Then for linear bounded automata, we are using context sensitive language. And for Turing machine, we are using recursively enumerable language. Okay. So already I said the finite automata is the simplest automata and the Turing machine is the most complex and the powerful automata. Next, we will see the history of the automata theory. So, it is originated in 1930 before the existence of the modern computers. Okay, so it was well-renowned computer scientist Alan Turing conceived the first infinite or unbounded model of the computation, that is the Turing machine, in 1936. Then this Warren McClock and the Walter, they were first presents the description about the finite automata in the 1943. Then later two computer scientists, that is G.H. Merle and another one E.F. Moore. E.F. Moore, they have generalized the theory of much more powerful machines. So this is about the introduction to the automata.